Hey everyone, in this video we're going to start chapter 4 where we're going to be talking about command-based programming. So this is really where we're going to get into sort of the architecture of FRC programming that a lot of teams use, alright? So this is really where we're going to start taking our FRC programming skills to really the next level, alright? So the first thing that I want to really talk to you about, right, is this sort of big question that I've kind of been sort of hinting at, and sort of Griffin has also been hinting at throughout the previous videos, right? How do we make our robot code more system agnostic, right? So the big idea here is how do we make the code easier to understand when analyzing a mechanism on our robot, right? Because think about it, right? We are writing code for a robot to compete in a high-intense competition setting, right? So you want to be able to read code as quickly as possible, but you also want other people to be able to explain and understand code as quickly as possible too, right? Because you're working on a team, right? The code, it doesn't just belong to you, it belongs to your team, right? So how do we make it so that everything is more relative to your system and makes sense when analyzing it at a system level? So we kind of use two options so far, right? The first thing were some methods within robot.java, right? So the first thing we kind of introduced was configuring the current limits. We had that method. We also could have, maybe a method that says move intake forward or move intake backward, right? Those are some options that we can explore with. We also have the ability to rely on robot.java for all of the mechanisms on the robot. But a big downside with this is that as you sort of evolve your robot, introduce more subsystems, and get more intricate with your commands, right? The things that you want to be able to control the robot with, right? It gets way too complicated. Having everything in one code class is a really bad idea. All right, so really, what we're trying to look for rather is a solution to really the two big problems we have, right? Which is basically just putting everything in robot.java, right? It really doesn't work, and it doesn't give you enough information immediately, right? It's going to take you a while to sort of read and understand. So we need kind of a new framework to deal with. And that new framework is called command-based programming, all right? So let's talk a little bit about how this sort of works first, and then a lot more into the conceptual idea. So this video is going to be 100% conceptual, and then in the next video, we're going to start looking at code and then analyzing all the different parts of a command-based project, all right? So in command-based programming, the first big concept is the idea of a subsystem. All right, a subsystem refers to the actual mechanism of the robot. All right, so this will include any motors that are on the mechanism, any sensors that are affiliated with the mechanism, and then methods within the subsystems class, right? So the parent class that defines your subsystem, right? That directly calls the .set methods on the motor, all right? So those are the three main responsibilities of a subsystem. All right, so here's an example, right? An intake subsystem, right? You would define and configure and write methods for one motor. For a shooter subsystem, you would do two motors, and then for a drive subsystem, it's usually four motors, two on each side, but that could change, right? So these are different ways we define our subsystem, all right? Then we also have the idea of a command, all right? A command will operate a subsystem in a particular way. In other words, these call the methods that exist in your subsystem class to move the motors. So here are some examples, right? We have a move intake forward command, right? This calls the set method of an intake subsystem, and it passes in a % value output of 0.5. That could be an example, right? Maybe you also have a run shooter command. This calls the set velocity method of your shooter system and tells the shooter to run at 5,000 RPM, right? So these are just arbitrary examples, but notice how in each example, we are calling the motor set method using a public method that we define in the subsystem class, right? So that's the main idea. Commands interface with the subsystem, okay? So how do we connect these together? Well, again, it's the idea that the command actually has the ability to control multiple subsystems, and one subsystem can be controlled by many different commands. So here's the idea, right? You're going to bind a button on your controller to a command. This command is going to call the appropriate set method in the subsystem, right? So, setting for % output, for example, right? And then that subsystem has methods that move your motors in the way that the command specifies, right? So it could be % output. It could be, and in the future we're going to talk about this, for a velocity, for a position, etc. All right? So you have a button calls command calls a set method runs the motor. All right? That's the main idea. So every subsystem has a periodic loop. This is very similar to robot periodic. So it's going to run everything regardless of the robot state. So that means autonomous, teleop, and then of course in disabled, if you choose to set any motors in periodic, it's not going to happen because again, disabled has those overriding safety features that prevents you from actually running any motors in the first place. All right. So this also repeats every 20 milliseconds, so it's going to run at the exact same timestamp. And there are many great use cases, one of which includes printing out data from your motor encoder. So remember, we had that lesson on shuffleboard. This periodic loop in the subsystem class is usually where you add your printouts for debugging. You can also get any information from sensors that are affiliated with your subsystem. All right, so there are great use cases for this case. And one of the things to keep in mind is that a lot of the subsystem is all about the motor, right? Like, what is the motor doing? How am I going to control the motor? What are the different ways I can control the motor, etc., right? So that's what the subsystem is about. Now, with the command, it gets a little bit complicated, but it's not too bad. So we start off with, there are 4 main functions that are defined in a default command. So like when you make a WPI command class in VS Code, you get these 4 functions, or methods rather. So the first one is initialize, and we're kind of used to this with robot init, right? It's similar to the init functions in robot.java. What do you want to happen at the very beginning of the command, right? That's what initialize does. Then we go to execute, right? And this is similar to a subsystem's periodic loop. So every 20 milliseconds, this execute loop will repeat, all right? So that's going to continuously repeat. And every time execute runs, it's gonna pull the isFinished method, right? So isFinished is a method that returns a Boolean indicating when the command should end. So for example, right? Let's say I want a shooter to spin at 5,000 revolutions per minute, or RPM. And I want my command to end, or I want my shooter to stop once I hit that 5,000. So I would put the logic that checks, hey, is my motor at 5,000 RPM? If so, return true because I want the command to end, right? So that's what isFinished is responsible for. Then we have end, which is basically saying, well, what do you want to do when the command ends? All right, so we kind of have these 4 methods that are critical to one command, all right? Then we have robot container, right? There's only one part left, right? And that's button bindings, right? And this happens in the robot container class, all right? And the robot container class is where you also initialize your subsystem. So this is where you do intake subsystem, intake equals new intake subsystem, all right? And something to keep in mind is that robot container is already initialized here within robot.java, right? So we have a robot container, and it's initialized right here inside robot init, all right? So in a way, you could say that robot.java is still involved because robot container is where you're going to add all your button bindings, right? So I guess robot.java is still involved, but at this point, robot.java is basically useless. So for now, you're going to shift the way you think about your programming flow, all right? So the first thing you want to think about is, well, what are the mechanisms on your robot, right? You want to ask yourself, what motors or sensors are involved in the mechanism? And these are the components, these are the objects, right? Those Talon effects objects that are going to make up the subsystem. The next question you're going to ask is, how do you want to operate the mechanism? So for now, we're going to be using % output control. This is going to change in the future, but these will make up the methods in your subsystem. Next, you're going to ask yourself, well, what are the commands? How do you want to control these subsystems, right? So for example, move the intake forward, move the intake backwards, drive command, etc. These are all ways in which we control our subsystem, and we write a class to specify the way we want to control it, right? And then finally, what buttons are going to be controlling the commands, and how are you going to hold the buttons, toggle, while held, etc., all those kind of things, right? And all of this goes into robot container, all right? Another thing I want to touch on, and this sort of makes up the backbone of command-based programming, is something called the command scheduler, right? So in order to run all your, because at any given point, right, think of it this way, right? You have a lot of different commands that you could run at once, right? Depending on all the mechanisms you have, you might even have commands running in parallel at the same time, all right? So every 20 milliseconds, we have this thing called a command scheduler that gets refreshed. And so for those of you who've taken data structures, if you know what a queue is, basically what's happening is commands are appended to the queue, and then they're scheduled to run in a specific priority, all right? So that's basically depending on when they're added, all right? So we're not going to worry too much about this for now, because this is going to be important way later on in the course when we talk about state-managed systems. Just for now, know that there's this thing called a command scheduler that runs your commands in a periodic manner. It allows you to schedule each command accordingly, all right? So just know that this exists, know that every 20 milliseconds is refreshed, and it's basically just a list where commands are scheduled to run, all right? That's the idea. So that is all I wanted to cover for command-based programming, all right? So in the next video, we're going to talk about making a new command-based project, and then we're going to talk about all the different sample code that comes when you build a command-based project, all right? So thank you so much for watching, and I look forward to seeing you in the next video.